Texan Global School. This class will analyze the concept of algebraic fraction or rational expression, its classification, and reduction or simplification processes. The quotient of two algebraic expressions forms an algebraic fraction. That is, the numerator will have an algebraic expression, and in its denominator will have another algebraic expression. Algebraic fractions are classified into simple and complex. Simple algebraic fractions are those where the numerator and denominator are polynomials. These are classified as proper in which the polynomial of the numerator is of lower degree than the polynomial of the denominator, and an improper in which the polynomial of the numerator is of greater or equal degree than the polynomial of the denominator. Finally, complex algebraic fractions contain one or more simple fractions in their numerator and/or denominator. Moreover, an algebraic fraction is simplified when it does not have common factors in the numerator and the denominator. To simplify these type of expressions, laws of exponents and radicals are used, or factoring processes to cancel identical factors as shown on the board. Let's look at the first example. We will simplify the following rational expression. As we can see, it is a simple improper algebraic fraction since the degree of the numerator is greater than the degree of the denominator. To simplify this fraction, we first obtain the prime factors of each numerical coefficient. Hence, we cancel those identical factors. In this way, the numerical coefficients are simplified. For variables, we will use laws of exponents since they are products and quotients. Remember that we must represent the result with positive exponents. So, in the case of the x, we will raise the x squared as x to the negative 2 and subtract the exponents. In the case of y, we will move to the denominator the y cubed and subtract the exponents. In this way, the simplified result is negative 5 times x to the 4th over 3y to the 6th. In this second example, we obtain the prime factors of the numerical coefficient of the denominator 10 and cancel identical factors with the numerator. Likewise, as they are factors, we will use the laws of exponents to simplify the variables by raising a squared as a to the negative 2, and the factor 2b plus 1 raised to the 4th power as 2b plus 1 raised to the negative 4. Finally, we subtract exponents, thus obtaining a times 2b plus 1, everything over 2. To simplify the algebraic fraction in the following example, we must factor both numerator and denominator, using the processes seen in previous classes. We can see that the numerator is a trinomial of the form x squared plus bx plus c. It is factored by looking for two multiplied numbers giving the independent term plus 4, and adding the same numbers, giving the numerical coefficient of the linear term plus 4. The factors are x plus 2 times x plus 2. The denominator is a difference of two squares. It is factored as conjugated binomials. We then obtain the square root of x squared, which is x, and the square root of 4, which is 2. We substitute in the conjugates, thus obtaining x plus 2 times x minus 2. We then substitute the corresponding factors to the numerator and denominator. Finally, we cancel identical factors, thus obtaining the simplified algebraic fraction x plus 2 over x minus 2. In this last example, we can see that to simplify the algebraic fraction, we must also factor. First, we have a common factor in both the numerator and the denominator. The common factor of the numerator is 7x cubed y, which, when dividing each term, results in the polynomial 2x squared minus 9x plus 4. The common factor of the denominator is 14xy squared, which, by dividing each term, results in the polynomial 2x minus 1. Analyzing, we can see that the second factor of the denominator can still be factored. It is a trinomial of the form ax squared plus bx plus c. It is factored with the scissors method. We then create all the arrangements where multiplying the left column gives us 2x squared, and multiplying the right column gives us the independent term 4. Once the arrangements are created, we eliminate all those with common factors. The terms of each factor are placed according to the remaining arrangement horizontally. The signs are placed in such a way that, multiplying in the direction of the arrows and adding these terms, results in the linear term, minus 9x. Remember that, if we multiply the factors, we can verify that we obtain the original polynomial. We then replace these factors with the original polynomial. After the entire expression has been factored, we begin to simplify identical factors. The 14 of the denominator is separated into its prime factors 2 times 7. In this way, we cancel the 7. To obtain factors with positive exponents, we move the x of the denominator to the numerator, using laws of exponents, as x to -1, and we subtract, thus obtaining x squared. The y of the numerator is moved to the denominator as y to -1, and we subtract, thus obtaining y. Finally, we cancel the factors 2x minus 1 from the numerator and denominator, thus obtaining a simplified expression, x squared by x minus 4 over 2y.
Texan Global School. Global online learning. Knowledge for the world. www.texanglobalschool.com